Hey everybody, I'm gonna walk you through getting your model set up in Rhino.Inside. I'm sorry, in Revit using Rhino.Inside. So it's essentially getting your model set up, getting your levels brought in, and then getting floor slabs associated with those levels. And this is going to be based off of your Rhino massings. I have 3 different massing styles to hopefully cover all different bases. They're ultimately going to be the same. In the end, we're going to need some closed curves in order to generate our slabs. But the way that you're going to kind of work through the massings is going to be slightly different depending on the design. So I'll walk you through all of those. But before we get started, let's open up Revit 2025. So whenever you're using Rhino.Inside, you actually need to open up Revit first. It's literally called Rhino.Inside Revit. So you open up a session of Rhino through Revit. So I'm just going to do a new model. I'm going to do Imperial Multidiscipline because I am working in feet, not metric would be if you're working in meters or millimeters or centimeters. But we're going to do Imperial, Project, click OK. Now I just have my model. It's going to open up. While that's happening, make sure you have this Rhino.Inside tab up here. This will ensure that you can run Rhino.Inside. Everybody should have it installed. If you don't, please reach out to IT. Also, sometimes it's in add-ins. It depends on how it's set up by the administrator. So if you don't see a Rhino.Inside tab, click on add-ins and you might see a button here for Rhino.Inside. If not, then you need it installed. But I have it here, so I'm going to click there. I'm actually going to click start. It's going to think for a second, and it's actually opening a version of Rhino within here. Let's think for 1 minute. All right, and then it won't open right away, but this toolbar will change and have more options in it. So now let me click start. And then it should launch a version of Rhino for me. Or no, I'm sorry, maybe I click Rhino, show Rhino window. Slightly different. But I'm in Rhino 8, that's the important thing. Revit 2025 does not support Rhino 7. So you'll need to make sure you're in there. The one thing that's a little frustrating is some of my presets and toolbars are not in here. And I think, let me see, my view templates don't look like they're in here either. You can set those up and install those separately, but for now I'm not going to worry about that. And what I'm going to do is I'm just going to open up my model. So let me open my Alright, so now I've got my versions of my models opened up. I'm going to save these as a copy because I don't want to overwrite these. Save as, just for the sake of making this quick. Okay, and so again, this is a session of Rhino that exists within Revit. And I've got 3 different approaches here. One is this like pure swoopy tower. This is going to be one that is more like the glass would be curved and it would be more of like an iconic twisting building. This here is what I like to call the pancake, where it's a stack of floors, but the glass would be vertical, and in this case they'd all be rectangles, I believe, except for maybe at the top it gets a little bit twisted. But the thing that's important to know about this is that you want the roof of the floor below to sort of merge with the floor of the floor above, so that you could imagine that this slab should actually follow this shape. Shouldn't just be a box, because then your glass is going to be hanging out and you're going to have some detailing issues. So what we're going to do is essentially merge these curves, and then here this is again is going to be a finally slightly different one, where it's like you've modeled it as 3 different volumes and you want to be able to treat those like slightly differently and have the tops merge where they need to. So let's start with the swoopy one, because that one's kind of actually, even though it's the most complex looking, is the most easiest. But before I do that, I want to do a couple things in my Revit model to get it ready. So I'm just going to take my Rhino and I'm just going to move it to another monitor. and I'm going to come into my 3D view here. One thing I'm going to do first is just delete these levels, because I actually want to create my own levels. Can I do this? Maybe it doesn't let me have 0 levels in the project. Let me see. Yeah, maybe I can't have no levels in the project. So you know what? I'm just going to call this, I'm just going to change the name of this to like test level. And I'm going to move it down really low because I don't have any floors below 0. So let's just get this out of the way for now. And then once we create our other levels, we'll be able to get rid of that probably. So now I have this clean Rhino model, and I'm going to go back into my Rhino, or I have a clean Revit model. I'm going to go back into my Rhino here, and I'm going to open Grasshopper. It's going to think for a second again. And now I've got this standard Grasshopper, right? And this will have all the plugins that you have within your basic Grasshopper. It's the same program, except again, it's just opening through Revit. And I'm going to keep saying that, and it might get annoying, but it's kind of important because it's really sort of how it functions. And so what you'll see is that you're going to have a few of these extra tabs here, like Revit and Revit Elements, that you won't have if you're opening up Grasshopper natively in Rhino. And there's also a Revit tab here that actually has a ton of stuff on it. And this is, you know, I think it has like over 200 components. So we're not going to use nearly all of those, but there is a ton of functionality in Rhino.Inside. And, you know, more and more we're figuring out how to use it to make the project more efficient and so on. Okay, so now let's set up our levels. To do that, I'm going to work from this Excel spreadsheet that I created. I'm just calling it like stacking chart XLS. So I'm going to save this. In here I have my floors and their elevations associated with them, and then the program. This is a simple stacking chart. On the smorgasbord, I talked about how to bring this in. So go back and reference that if you haven't gotten to that yet. But you should know how to bring this data in, and I'm just going to do it quickly to recap. But I have my stacking chart. It's saved into my Slabs Rhino.Inside folder. So I'm actually just going to close this for now, and I'm going to go into Excel Reader. All right, read. I want it to be true, so I'm going to do a toggle, and I'm going to go pretty fast here because you guys should all be up to speed with the smorgasbord. And then the file path. Right click, set an existing file. Going to navigate to Dropbox, teaching, rethinking BIM, class recordings. Nope, sorry. Software demos. Nope. Video tutorials. Third time's a charm. There we go. All right, stacking chart. So now, if I do this into my path, my data that's coming out of here should be, sorry, this is the error. If there's an error, it'll come out there. The data is what I care about. So this is showing me, you know, the first column is basically program at the top, retail, office, hotel, etc. I want the second branch of data and the third branch, so I'm just going to do an explode tree, which will give me each of my individual branches. And it's yellow because I should have 3 branches, but I only had 2 in here. So if I click plus, I now have that. And then if I take a look at the data that's coming out, here is a list, that first column of the different program. Here is the floor numbers, and here is the elevations of each. So I'm also gonna, you know what, before I do this, I'm actually gonna do a split list. And I'm gonna take the first item off the top. So this will ask me where I want to split the list. I want to split it at index 1. And this gives me program, this gives me sort of the header at the top, which I don't want. I just want the data. So now if I do this, now you'll see I have I just have my elevations without that text of elevation, and I just have my floor numbers without the text of floor numbers. So that's good. Now this is going to be pretty easy. I want to create levels at each one of these elevations. So I'm going to actually use a levels component, or add level. And it's going to ask me for a level elevation, a name of the level, and the type of the level. So the type of level, if I come back into, we'll start at the bottom. If I come back into Revit, and you'll notice you have to do a lot of kind of minimizing and maximizing to get the everything to like hide and show windows. It's not the best. Revit will always be in the back, I think, and then Rhino, and then Grasshopper, so you have to sort of just kind of minimize things in order to see things, especially if you're only working on one screen. When I work on this, I usually have it set up on 2 monitors, and I kind of organize it so I don't have to hide things, but for the demo, I'm going to have to do that. But if I click on this, this is my level type. Level, 1/4 inch head. There's a few additional ones here, but this one is fine. I'll use this one for now, but that's what it means when it's referring to level type. So I'll open this back up again. The elevation's the most important part, but the name also is going to be critical. So what I want to do actually is I'm going to create the name myself. So I'm going to do, I could use these. I'm going to use these numbers here, and I'm going to use a concatenate component. And I'm going to write level, and then I'm going to plug in, you know what, I'm actually going to add a plus in the middle, and I'm going to add a space in there. I think I can put a space, let's see. Or you know what, let's just do an underscore. So this is how concatenate works. You can basically string together different text. I could have put the underscore there, but you can add and just continue to sort of string text strings together. And then I have my level name, or number. So what's coming out of this, as you see, is actually it says level 1, level 2, level 3, etc. Right? So these are going to be my level names, and my elevation is easy. It's just these here, and I'm going to plug this in. It's going to think for a second. This component will turn black. That means that it has processed data into Revit. So it means it has created data into Revit. So to this point, we haven't seen a Rhino component turn, or a Grasshopper component turn black, only gray, red, or orange, depending on whether or not it's succeeding. This is a new thing where it turns black to show that it has actually pushed data into Revit. So if I close everything here, I now have all my levels, which is pretty sweet. I'm going to take this. I think I can delete this now. Can I? Yes, cool. So I can delete that, and now I just have my clean slabs, or my clean levels, and they're at the heights of what they are in my stacking chart. So this is a really quick and easy way to create levels based on your stacking chart. And we're going to need these levels to associate our floors with them. Okay, so now that that's done, I'm going to come back into here, and like I said, we're going to start with the surprisingly the twisty one, which is the most simple. And I should have done this before, but I'm going to clean this up a little bit and grab this number and call this level elevations, because I'm going to use that a few times. So let me pull this over here. And to get it with this massing I have on this layer called DP, for Design Proposal Overall Massing. So I'm going to use a geometry pipeline. I'm going to use the DP underscore overall underscore massing, and I'm going to double click on the brep, and you see that now it's bringing this brep in. And the next thing I'm going to do is I'm going to want to just cut this overall massing at each elevation to get sort of a contour. So you can see I did it to test it out, and so I have these curves, and that's what I use to kind of build these, but I'll show you how to do it with this so that it's parametric. I'm going to then do a BREP plane intersection, because I'm going to create a series of planes that intersect with my BREP. So that's my BREP. I don't have my planes yet, but that's going to be easy because I have my heights here. I need to create a point at each one of those heights, so I'm just going to do a construct point. Actually, let me kind of start at the end and work backwards. I'm going to create an XY plane, which is a plane that extends out infinitely in X and Y, but I need an origin. By default, it's at 0, 0. I want to give it a list of points so I can have one at every elevation. So all I'm going to do is do construct point. I'm going to, for my level elevations, I'm going to do Z, and now you see I've got a whole bunch of points here. If I plug this into my XY, I now have a plane at every one. And then what I can do is I can then go in and say my plane that I'm cutting at is that. It's going to think for a second, and then my result is now that. So now I have essentially a floor slab cut at every single floor. If it cuts through a curve, it would give you a point, but we don't have any points, we just have curves. So these are our closed curves as a list. And now basically I need to create a floor from those curves. To take another step back and explain this a little bit more, is the way that Revit works is that floors are a sketch-based family. So if I click on architecture and I click on floor, I need to set a work plane. So let me set this. I'm going to click on, how do I do that quickly? Just trying to find a fast way to do it, but you can click on architecture, set work plane, and then you can pick a plane, or actually you can pick a level. So let's pick level 1. So now if I come back to floor, it's a sketch based method. So I'm going to give it essentially a boundary, and I could give it any shape that's in here. And this is important when you're giving it shapes in Rhino. You want to try to make it fit into one of these categories, which are like a polygon, rectangle, circle, tangent arc, fillet arc, and so on, right? But just to show you, essentially I sketch out a line and hit hit check, and now I have my floor, generic 12-inch floor. All right, now this, if I double click on it, again is then based on this sketch. So if I was to do something like this and sort of sketch a line that looks like that, that's the shape that my floor will take. So it'll take whatever shape of a curve that you give it. So we have to use that logic when we're working in Rhino. Okay, I can now give it a curve and it can draw it for me. It's different than importing. If I was importing it, it would actually just be creating a dead version of that geometry without any sort of Revit parameters or Revit flexibility. That's not what we want to do. So if I come back into here, I now have those curves. I'm going to go into architecture, and then there's add floor. One other thing, again, if I take a step back, the actually pushing the geometry into Revit is pretty simple, or it's usually one of the most straightforward parts of your process. It's getting the geometry right, making sure the geometry is clean, and making sure the geometry is compatible. That is essentially going to be where a lot of your effort goes. So it's going to ask me for a floor boundary profile. I'm going to give it these section curves. And right now it actually has done it already. So there's all my floors. Okay. I'm going to come back into here. My floor type, so again, that was nice and easy. It should associate it based on the level, level 29, level 21. It usually does a pretty good job of figuring out which level you want it to be on, and there's no offset, so that's good. Sometimes it's good to be prescriptive and tell it exactly what level you want it to go to. So I'm actually going to, I have my levels here, right? These are in the same order as this. So this is 31 levels. This is 31 curves. I'm going to just take these levels actually. I'm going to graft it because this is grafted. You can tell by the dotted line. I'm going to graft this and I'm going to plug this into my levels. And it's now going to turn black. Before it was, if I undo that, it's hard to undo stuff in Rhino.Inside. It was probably giving me a warning of something about like no levels provided or something. And that like it's going to try to assume what level you want. But now we're telling it exactly what level to go to. And then if I come back in here, it should all look the same. Everything looks fine, but the levels are being defined in Rhino. All right, so back into here, the last thing is my type. So if I come into my floor type, I can right click here. I can go into category here. I can go into floors, and I have a few. So maybe I want this to be a 10-inch concrete floor and not just a generic floor. So I'm gonna pick 10-inch concrete. That's what my type is now. I'm gonna plug this in. And before it was using generic floors, it'll use, I don't know what it'll use, but now it's using concrete. So if I click on this, I can see that it's that. Again though, because it's native Revit geometry, I can always come in here and I can change these things as needed. There's some curvature occurring here, but it seems to be able to handle it, which is good. And so yeah, now I've got these slabs all set up. And for any of you that have worked in Revit before, if this was a rectangle slab that was copied up 50 times, it would be nice and easy to do. But if you had to try to get all these profiles into Revit, it would be quite cumbersome if you're doing it by hand. But anyway, we're good now. This is set up, ready to go. So the next thing I'm going to do is show you how to do that a little bit more of a complex geometry. All right. So I'm going to actually take the levels I have, the elevations I have, all of that stuff's good. But what I want to do is I want to bring in those 3 different volumes, and I'm gonna extract the surfaces a little bit differently. Again, you guys can use different methods and combine methods. As I mentioned, sometimes it's a matter of just using one straightforward approach. Sometimes it's not so straightforward and you have to sort of mix and match things to get them to work a little bit. Okay, so I'm gonna bring those items in as geometry pipeline. So I'm going to do the 3 pancake layers. So let me real quickly do geometry pipeline. I'm not going to spend time cleaning up the definition, but you guys should be doing that. Geometry pipeline, the layer is DP retail pancake. Okay. Is it coming in? Yes, so I've got those. And then office pancake and hotel pancake. Okay. Okay, so what I'm going to do is then I'm just going to merge these 3 together. So I've got that, I've got office, and I've got hotel. Now, one thing that's a little bit different, I have all my referenced extrusions. The thing that's a little bit different about how this will work is that there's no guarantee that all these things are going to be in the right order. So I'm going to take a moment to just get them all in the right order. The way to do that is to do a volume component. So I'm going to get the center of each one. Another actually cleaner way to do this is to do a bounding box, which will give me a bound around each box, hence the name. So you know what, let me organize this a little bit better so you can see what I'm doing. So I've got my bounding box there, and then what I can do is deconstruct the box And I'm actually, there is a deconstruct box, but I'm going to do deconstruct brep because I want the bottom face of the box. So this is going to give me 6 faces for each box. I'm going to do an area to get the center of the face. And then I have essentially every, all 30 of these volumes with all 6 faces for the 6 sides of the cube, or of the, not a cube, I guess, rectangle, box, whatever. And so I'm then going to deconstruct those points. I think it might just be deconstruct. Yeah, okay. So these C's are the center of each face. I'm going to deconstruct that. I just want the Z value. I'm going to sort the Z values, the keys, and then I'm going to sort the faces. And then the first item in this list, but actually, you know what I can do? I can sort the centroids. So yeah, if I sort and I get the first item in the list, I'm actually getting, you know what? I can do it with the centroids. I'm going to sort those instead. So what's coming out of here now is a list of points. And because I'm taking the first item in the list, I'm getting the lowest elevation. And you'll see actually, the way this is organized right now is it's going from highest to lowest, and then it's starting again and going from highest to lowest. So we would actually have a problem if we tried to associate our levels later on. So now I have these, right? These are all my centroids. I'm going to deconstruct these again. Take the Z, and then I'm going to actually flatten this and sort this list, which is going to sort all my points from the lowest one to the highest one, right? So now I have 0, sorry, once it's sorted, it's going 0, 20, 40, 60. Those are all my elevations, right, that are sorted. You can see here, they're not. Because the way that this is pulling in the data is it's not essentially giving it any bias as to higher versus lower. It's probably just based on the order in which it was created, and you never know how that was done. So what I'm doing here is putting a little bit of sort of like not redundancy, but it's like it's like a check or an additional set of operations to be very prescriptive about the order in which things are coming in. And we describe this as calling the script bulletproof, right? It's like, how can we make it so that it doesn't break? We want to try to be as diligent as possible. So this is a technique that you might find yourself using a lot. It seems like it's a lot of additional work, but it's going to ensure that everything's coming in order. But what I actually have to do is I'm going to come all the way back to here, and I'm going to grab these and plug these in. So now all my extrusions should be in order from highest to lowest. So if I do list item and I plug it in here, I'm going to hide a lot of this. So it's the lowest one. And if I was to do a slider from like 0 to 20, let me just make this wireframe for a second. You can see that the boxes are going up. So just to illustrate to you, if I didn't do that and I took my list item out of just this merge without sorting, they're not the same, right? So the order here, it's going to be different. See, the order is not synced up, so I'm going to have problems. I want it to go from bottom to top when I scrub through the lists. So that's a little bit of a side thing. But what's happening now is I have now, let's put a geometry placeholder here, and I'm going to call this sorted pancakes. All right, cool. So now that we've got that, what we actually need to do is grab the bottom of this and the top of this for every single thing. We're going to take the bottom and the top, and then what we're going to do is merge these two together so that it creates one slab. So what it essentially means is grabbing the bottom face of every one of these, the top face, we're going to have those in two different lists, and we're essentially like almost like a deck of cards. We're going to shuffle them together in a way that we can merge the ones that are overlapping with each other. So from that, what I'll do is I'm going to, I have my sorted pancakes. I'm going to do another deconstruct brep. Another deconstruct brep here, but it's not on the bounding boxes. It's actually on these. But I'm going to do the same thing with the area, where I'm going to get the area of my faces, gives me the centroid. I'm going to deconstruct them. I'm going to have my Z's, right? I'm going to sort those. And then I'm actually going to get, I'm going to sort my faces as well with those. And I'm going to do a list item. And if I get the first item in every list, let me hide some of this stuff so you can see. The first item in every list is the bottom face of this. Okay. I need the top face. That's going to be the last item in the list. Because you know what, let me walk through this a little bit more carefully, because I sort of blew through this before. If I look at my centroids, the one that has the lowest Z value is going to be the bottom face, and the one that has the highest Z value is going to be the top face. These ones all should have the same Z value because of the way the geometry is modeled. If it's twisted or angled, they won't, but for our purposes they do. But I don't care about those, I only care about the top and the bottom. So another trick to get this is to basically, I can either do this plus, which gives me item -1, which is basically the list wraps, and it gives me the top item in the list or the last item in the list. That's one way of doing it. Another way is you can actually just reverse the list. So reverse list, plug this in, then plug that into there, and now I have my top and my bottom. So what I'll do is I'm going to call this, this is a surface, and I'm going to call it pancake bottom. All right. And then I have my other surface, which is called pancake top. All right. So one last thing we're going to need to do before we combine them is that the bottom doesn't have like a corresponding top, pancake top to it, and the top doesn't have a corresponding pancake bottom. So we need to take that item out of this list, and we need to take this item out of this list. So pancake bottom, I'm gonna can I split it in index? Let me see. Split tree. I'm going to split the tree. So as we've talked about before, trying to maintain the data structure is good. I flattened something over here because basically I just needed a list of, I needed this data structure here to match this. But let's try to keep this for now. I don't want you guys to get in the habits of flattening things and then regrafting when you can avoid it. So it's going to ask me the tree to split, and I'm going to say this. So, okay, so yeah, avoiding, sorry, I had to just run quick. Avoiding splitting, it's asking for a mask. So what I can do is, let me see. I'm going to use a path mask. So I think what I can do is use a tree statistics. This will give me all the paths of the tree and then the number of paths. So I can do a list item again And then I should be able to take the first item in the list as the mask at which I want to split it. So yeah, cool. So what it's giving me is my first trim surface and then all the other ones. Full disclosure is I am actually trying to be diligent about my data tree management as well. So some of these things I'm actually implementing into my workflow now. So this technique is not something I actually would have done a while ago. And so, but anyway, what I need to do is now I have like to just kind of then again further define these surfaces. I have my ground floor, okay. I have my other floors, right? Okay. I then have, I need to split this because I want that, I want the pancake tops, I want the, or these are other floors, let's call it bottom. Okay. So I'm going to use this same masking here, except what I'm going to do is I'm actually going to do the reverse list here for this path and do that. So I end up having my all my other floors, and then the top by itself is what we wanted. So we wanted these are the other floor tops, I believe. Yeah. So this is the other floor top. And then this is my roof. All right, cool. So what I need to do is take my other floor bottoms, basically, and my other floor tops, and kind of merge those together. Because the data structure is similar. Actually, I have to renumber these. Or how do I? Because right now this says 0:1 and this is 0:0. I actually want them to I want them to basically be in the same structure. So if I go into params, or no, I think it's in sets, bear with me, I can, let me see. There is a way to renumber the tree. Give me front tree. Bear with me. All right, thank you for bearing with me. Just needed to do some research. What I found is, so this is what I ended up with, and to try to show you how to do that, you can actually use a tree branch component. Plug in your tree into that, and then it's going to ask you for paths. So I'm going to use tree statistics, and this is going to give me my paths. I'm going to do that, but instead of maintain, I'm going to right click on this. I'm going to turn off maintain paths and have renumber. So now I have a new clean set. So if I do the same thing here, Control C, Control V, I end up with the same thing. These two, 0 to 28, 0 to 28. So now if I merge these, I should get a data tree that basically has two curves in each, that each represent each floor. And so I like to check these things every once in a while. You know what, I'm actually going to hide everything, and like, you know what, let me hide this up here to just make things a little bit clearer. Hide that. Okay, so yes, so that's good. I've got basically my overlapping, and so on. And because they're in the same data tree, I can basically, each one is in its own branch. So I have a branch that represents essentially the overlap of each floor. I can use an intersection component here, which basically, and then use this shape region union. And if I take this and I plug it in, I get a nice curve that gives me boop, boop, like that. Perfect. Exactly what we needed. Nice and clean. And like, let me just hide this for a second. You see how I'm getting like a really, really awesome clean slab there. This is pretty satisfying. I like when this goes like this, because again, this would be a tremendous amount of work to try to figure out what that overlap is. So here we just have it automatically. So when you start to put your glass, it'll basically have a clean termination at the top and the bottom. Okay, so we're pretty close to done. What we actually just need now is to put we need to get the ground back in there, and then also the roof. So I'm just gonna do an entwine, and I'm gonna take actually, let me do this should work. So let me try. I might have to play with these data trees a little bit, but that goes in the middle. My ground floor goes in there, and then my roof goes in here. Let me see what comes out. That is not what we want. Let me see, hold on. That what if I grabbed this before I put it in? Still not what I want. Let me do one quick little bit of research here. Okay, so I did a little bit of research, and it seems like this might be trickier than I anticipated. So we can flatten it at this point, and honestly, losing the data structure, I'm not too worried about it, because this is going to go right into Revit anyway, and we're not going to maintain the data structure once that happens. So let's just do a flatten. I actually think if we do, yeah, flatten this, and then we merge, we should have the ground floor, then these two, or sorry, all the middle floors, and then finally the roof goes in there, and we've got all of these in order from the ground up. And now this is just the same as previously. So add floor, the boundary profile is this. It's gonna, why are you giving me a problem? The import, oh, okay. So what's important to note is that this merge for some reason is being funky. What if I flatten this? Okay. It's important to note that for a floor, you can't give it a bunch of curves in a list like this. It has to be grafted. And the reason, I'll illustrate the reason quickly, is because technically in Revit, you can have two floors that are the same, that are two different curves that are part of the same floor. Okay, so these are part of the same floor. So if you feed it more than one curve, it's going to assume you're trying to do that, but what we're actually trying to do is create one on each floor. So and up here that was it was grafted, so we didn't have that problem. So all I'm going to do here is I'm going to graft these after I've kind of cleaned them up and flattened them. It's going to think for a second, and then we've got what we want. Another thing to note is even though we are giving it surfaces, it's smart enough to realize that even though it's looking for a boundary profile, it'll extract the edge of the surface and use that. And then last but not least, let's bring my list of levels, which is from over here. I'm going to plug this in to here. And now we have a nice component working cleanly. If I go into Revit, I can see them all. So yeah, so now there's those. I'm going to select all my levels real quick to show you guys something to just clean this up. I'm going to turn this off, just my levels. I'm going to right click and I'm going to say maximize 3D extents. So now the levels encompass the whole model. So it's easier, a little easier to see where everything is. Maybe what I want to do too is I might have to just refresh this, recompute. Something happened with the levels when I did the extents, but that's all right. My type, you know, I'll cut and paste this because instead of dragging that wire all the way over, but now I'll just use the same concrete floor type. All right, so there's the, you know, the strategy for if your building looks like, you know, if your building looks like this, that's how you're going to want to approach it. Option 1 is the one we did previously, is that. So let's finally do this one. This one we're going to use a little bit of both techniques. I'm going to basically just do like a contour, and then we're going to try to find the levels that overlap and then make one slab of that. So for example, like this one here, this is the hotel program. We want that to be the interior floor slab, but we also want this outer portion to be part of it for like a balcony or something. Same thing with the office to the residential. So we need to slice this up and we need to find the overlaps and create a clean slab from that. So what I'll do is I'm going to grab these three, copy and paste them, and instead of the retail pancake, it's called retail stacked. So let me just do retail stacked, office stacked, and then hotel stacked. All right, and I actually think I might actually just use all of these together. Okay, cool. So now what I'm going to do is, what I've done is I've made sure that the top of my stacking chart, or exactly where the stacking chart cuts, is here. So this is 60 feet off the ground. So yeah, let me see. Without my little shortcuts and all this setup, it's a little bit tricky endpoint. That is 60 feet, which is, if I go back into my stacking chart or my numbers that are coming out of here, you'll see I have a 60. It's the fourth value down there. So what I've done is that's important to do is to make sure this model here aligns with your stacking chart, right? So if you try to cut at the 60th floor, but your volume doesn't go that high, then obviously you're not going to get a cut. It's going to miss it. So I've got this set up. Also make sure your surfaces are clean and flat and all of those things, or it might also cause some problems. So I've got my referenced extrusions, and what I'm also going to try to do is get my planes here. These are my intersection planes, right? So let me just do a plane component, and I'm going to right click, call this intersection planes, or floor intersection planes. Okay, I'm going to bring this down, and I'm going to do a B-rep curve, B-rep plane. And actually, I think if I plug, let me see something. If I plug all my B-reps in here, intersection failed because I don't have plane yet. Oh, because it's got the world XY. And what I'm going to do here is I'm actually going to do a graft on this. Plug this in. So I'm going to have, let me see, a series of planes here. So what you'll see is we actually are going to have this interesting data structure. Polyline curve. Okay, I'm back. I had to just pause for a second to test something out, but I think I've got it working. So to recap, we've got our merged volumes coming in here. Our floor intersection planes are coming from up here. I'm going to graft those, and I'm going to just run it through here, because what that's going to do is it's essentially going to give me the ability to group by intersection plane, because where these things are falling on the same intersection, I want to be able to kind of merge those later on with the same technique as before. What we're doing is we're basically using techniques from this and techniques from this and kind of combining them into one, right? But because I'm contouring it from the ground up, I don't have to worry about resorting everything. My intersection planes are already in order from the ground up. So I don't have to do any resorting or anything like that. So I'm going to get an error because intersection failed, because some of the planes, it's going to test every plane against every volume. And if like this plane down here can't hit this one or this one, it's going to give an error. But it's okay because I have a bunch of these curves here. And what I need to do is basically just clean up this list a little bit. So I'm going to do a simplify tree. Or no, I'm sorry. First, I'm going to do a clean tree. I'm going to plug my tree into here. It's going to ask me if I want to remove null items, invalid, and empty branches. By default, that's false. I do want to remove empty branches. So I'm just going to take this, plug it in here, and do true. So I'm ending up with, if you see what's coming out of here, I have a lot of empty branches where there's no data, and that's because that's where it's testing that intersection plane against the B-rep that's not there. So it hits this one, it doesn't hit here, so it gives no result, it doesn't hit here, so it gives no result, and so on. And in some areas, you'll actually have, within the same intersection, you'll have two, and that's where we want to merge them. But what this does is it essentially takes those out, right? And then what I'm also going to do is I'm going to simplify this tree, which is going to take out unnecessary data structure, because you'll see here there's a lot of redundancy, or there's this 0 here, which actually the whole way down is a 0. It's just adding unnecessary complexity. So if I do this, you see it sort of cleans it up, and it's actually easier to understand now because you have 0 is intersection plane 0, the other 0 is volume 0, 1, 0, so on, right? We're going to have some where we have 2, and that's where we want to merge them. So the last thing I'm going to do is I'm going to shift the paths. So what if I do that, what it will do is it'll take ones that are associated with the same intersection and combine them. So see this? This is essentially this area here, where we have two curves essentially at the same intersection plane. So now I can just do that region, or what was it? Combine region. Let me check up here. Region union. Do that, and actually now I have, if I come here, hide everything, hide these, I have essentially those curves like I want. And it goes up the whole building. So this is actually done. I should have 30 curves. What do I have coming in here? 31. There might be, we probably don't have the roof included in here, but that's okay. So what I'll do, just for the sake of making this 30, how many intersection planes do I have? 31. For some reason, let me actually, it might not be cutting at the top. Let me try something. Sometimes you have to cheat it a little bit to just get this to like cut at the top. Let me see. What if I move this up a little bit? Yeah, I think that's working now. So now I have 31. Cool. So now if I do my add floor, I can have my boundary profile as this. and that's working. And then let's just grab our levels from up here as well, which are coming out of here, right? And then the last thing is I'll move this over here, and again, I didn't clean this up. You guys gotta take some time and clean up your definition. Take the type, plug it in there. To make things not confusing, actually, let's bring this down here because this is associated with this. I can even bring this down a little bit. You can see this is a bit easier than the middle, but let me just pull this over. There's all my floors, and if I go into Revit finally, I now have those as well. So very, very, again, like, would be a little bit challenging to get all these in. Maybe not as hard as kind of the first two, but like getting this perfect intersection and all that would be tricky. But now I have 3 different strategies, 3 different floor slab styles all ready to go.